Hello, and I thought today I would continue our conversation around Databricks. In part, it's relevant to kind of the second half of the course. Also, it's cool, right? So relevant within the industry as well. So what I've got here is basically something that I'm not going to share beyond this conversation, but it is essentially a capstone project for Databricks' Academy, which is essentially their training program, right? The part of this that's pretty interesting, though, is that it's all about um, being able to show and demonstrate the use of streaming and stream processing in essentially Spark. And also it relies also on and utilizes that discussion I had last week around Databricks Delta. So again, as a reminder, as a data scientist, you might be wondering, why would I care about such things? Well, oftentimes the analytics that we do is not necessarily on static data. Instead, it's on data that is in motion. So in the world where you have streaming data that you need to be able to do your analysis quickly, it can be quite challenging if you're not using something that's built for that, and that's exactly what structured streaming is about. So as an additional reminder, I talked about Databricks Delta and the paradigm of bronze, silver, and gold. So the idea being that data lands in a data lake in its raw form. It is moved into bronze primarily so that it's more accessible. It's about standardization of data types. And in particular, it's about moving it from whatever it was into something like Databricks Delta. And then during the silver stage, you do some refinement. You improve it for use, get it to where it's actually queryable for the destination, and so on. And then lastly is around gold, which is around aggregation. So being able to do your aggregate calculations as needed. So to roll up basically. So you're doing a lot of group bys or summation and aggregation type functions. So to kind of step through this, I'll highlight the key things. A key concept is oftentimes you need to be able to deal with the structure, and the structure of the data you're dealing with may not be tabular in nature. So you can see on the screen here, there's an indentation inside of the schema that's being defined. And the schema is being defined using some kind of clunky sort of words, but this is how you have to do it in Python to describe a schema that is basically, this is the record structure that we'll be seeing. So at the top level, there's an event name, then there's basically two top level variables or names, attribute names, event name and event parms. Underneath of event parms, there's a series of things that are nested underneath of it. And this is not that unusual of an sort of structure. You'll see this a fair amount. Also, some of the stuff that you care about, like client event time, is actually buried down inside of this as a timestamp. Timestamps are an offset from essentially the beginning of time or something else, but they're not terribly useful for display and conversion. So instead, we oftentimes will convert them to a date time sort of structure, and that's what this is taking it to a date. So it's taking this nested item, which was event parms dot client time event time, and exposing it as a new column inside of the Databricks frame or the Spark data frame named event date. And then also we go ahead and remove from that same data frame anywhere where they're null. So if there's any event, basically in this case it would be client event times. If there are any of those that are null, we don't want them in our final data frame, so we remove them. And then we turn around and use this write stream as a way of taking from that data frame that we've read and turning it into a streaming operation so that it actually streams it using the structured streaming approach, which we've talked about, to write out. And in this case, we're writing it out as a delta table or a delta file. It's not a table per se, but you can convert it to one easily at a certain location. Basically, in this case, it's going to be to bronze path. So whatever function is passed in, whatever value is passed into this function for bronze path is where it's written to. There's also this concept of a checkpoint. And checkpoints are necessary to avoid reprocessing the same files as they're being ingested. So it saves off the fact that it took care of certain information. You can give a stream a name, and that allows you then to be able to access it by name. And then also there's this concept of an output mode. the two ones that are most typical whenever you're dealing with a write is either append, or there is one which is complete, which basically writes everything it's ever seen out. So that's kind of like a batch sort of operation. So in this case, I've written this function up here that takes things from the raw zone and ingest it into the batch, and that's what this is doing. Part of the training process, they have a series of unit tests essentially that you've got to pass, and in this case I've passed them. So the next step though is sometimes you'll want to combine multiple frames together. It's similar to a join that you do in a database, or a join that you might do with data frames, where you're taking things from different sources, combining them together to form something new. Generally speaking, we do that as a means of enrichment or a means of augmenting data, although sometimes you need to do it in order to make sense of the data that you're getting. And it's what we're doing here. So to do this, we basically load in the data that we care about from a location and essentially create a data frame with it. And that's really not any more complex than that. So once we have that data frame, we can then set about using it with our other stream to merge them together and doing a join. And in this case, we want to join to a device ID. So the idea is that this is a fictitious gaming company. You're receiving information, telemetry coming in from the various things out there running. So maybe you've got an application that's a game, and you've distributed to both Apple Play or Apple Store, whatever it is, and then Google Play. And you want to be able to tell what their people are doing. One of the things you might care about is what kind of device it is. And so what we're doing is taking a device ID and looking up, based upon that ID, we know what type of device type it is. And that allows us to be able to enrich our data so that you know that not only is it's Alan's device, but Alan's device happens to also be an Android device. And so we take those two basically items together. So we've got one stream that we're joining on in this case, a static data frame for enrichment. Equally well, it could be joining on a stream, but if we're joining streams together, generally speaking, you need a window to do that stream join operation on, because you have to have units of time. And inside of structured streaming, we view a stream as essentially an unbounded table, right? So the idea here is, in this case, we're just enriching it with essentially a lookup table, for lack of a better word. Once we've combined those things together with that join statement based upon this device ID, which we actually extracted in turn from down inside of that nested sort of structure inside of the message that we're receiving, we can then select the columns of interest and write those out to another stream, again using a checkpoint so that we make sure that there's no duplications going on. We give it a name based upon what was supplied to us in this function, and we say that we want it to be a delta file that's being created. That means it's got a structure. There's some ACID sort of stuff going on, so we don't have to worry about incomplete writes. So you're guaranteed that it either succeeds or it fails, not partially succeeds, which is problematic and one of the challenges you have with data lakes. Also, we're saying that we want to append it to whatever's been written previously. So if there happens to be something there before, we add to it and augment it, not necessarily replace it. And then we start that stream running against a certain location. And when we do that, it's looking for things that are coming in, and when it gets them, it writes them out using the micro batch architecture. And then again, unit test to make sure that we did it correctly, and so on. And then moving that next step is going from the silver to the gold. This is when we're dealing with aggregation. And in particular, what we're trying to aggregate on this is based upon the week of the year, and also we want it to be a unique device ID. So the number of unique devices per week of the year. And the reason we might want that is to know how many users you have in your system, not how frequently those users are sending stuff into your environment, but how many unique people are using your stuff by week of the year. So there's a function that we have to utilize on a stream called approximate count distinct. Distinct counts are problematic in a lot of ways whenever you're dealing with stream processing. So you approximate it and you give it a certain threshold and so on. And we aggregate it up, so it's basically doing a count off of the grouping by the week of the year based upon the date that we extracted out of that timestamp. And then we give it a new name so that it has a more meaningful, potentially within the organization, meaningful name rather than just some ugly aggregate count device ID or something, which is what you might get otherwise. And then we turn around, we take that result, which is itself a stream, and we want to write it out to another location. But the difference here is we're going to do a complete in this case. And what that means is that while we're listening on this stream, if something comes in, we're going to write it out, and then we're going to write out everything else again. So it's basically fleshing out the entire contents every time it gets something new as it's running through its regular run. And so the end result of all this is we want to create a table so that we can do a certain amount of visualizations. And this is very much what we do in this sort of pattern. And you take this sort of approach, this pattern, and apply it at scale to an organization so that you're taking all of their data, you're landing it in a raw location, and then you're taking all of that raw location data and moving it into something that is essentially that bronze layer, that layer of basically being accessible, but yet not necessarily consumable. It may be noisy, so you may have instances where just as we've removed things that didn't have essentially a date field set on them, that's probably a hole in the data that you don't really particularly want to have, right? So getting rid of your nulls is part of what you're doing when you're going from potentially your raw even to your bronze, so that you're just kind of not bringing in stuff. But a lot of times you'll do much more of that when you're going from bronze to silver. Silver is typically constructed to meet a business need. There's something you're trying to accomplish. There's a reason you need to know those values. You may not take everything from bronze to silver, and you only create things in that highest level of aggregation, in that gold layer, whenever you know that you really need it, or it's highly likely you're going to need it. You're not just going to do it for everything. And that's a key distinction between this Delta Lake and Data Lake patterns and a data warehouse. In a data warehouse, you basically establish your schema, your dimensions, everything that you're going to model, and then you do it all. And you do this all based upon kind of mapping your data to a model of your data, so that you can then do reporting in a predictable sort of way along certain dimensions of, be it time or products or whatever it might be. We don't do that with a data lake or a Delta Lake. Instead, we get the plumbing in place. We get stuff into the layers to where it can be used and accessed, and you know that it's reasonably good, but there's probably still some stuff that needs help. And then you only do that next layer of refinement when there's a need. And that's a key distinction. We don't do it for everything. We may not even cleanse everything, but we do cleanse that stuff that we know we need. And then once we've done that, we typically will industrialize it. So if this were something that were being done for real, we would start looking into how do you schedule this to run on a regular cadence. And so that's the kind of a key concept here. Is it's about setting the plumbing in place and then starting to run through things on a regular sort of basis. And so that's basically the what I had to talk about as far as a real hands-on sort of discussion of streaming, and understanding this is sort of streaming. It's streaming from a file system. That's probably okay though, because oftentimes you'll have things that come in over time that are picked up and streamed. And they may be dropped onto your file system in an ongoing fashion. A classic example of that is you might have a job that runs every so often that either pushes or pulls data to a location using perhaps even an arcane technology such as FTP. It's still very popular, very widely used, and very old. But it is a way that you may ingest data over time, and you may wake up periodically as a system and go out and decide that you want to go check for stuff to do. And so that's where this kind of comes in. And also, while there's not a ton of analytics going on here, there is a certain amount when we start talking about, obviously the filtering, that's kind of important. So you're getting rid of stuff you don't care about. But we are doing aggregation on a stream, and that is pretty interesting, because you are doing equivalent of a group by or a roll up on something, and we're not doing anything real, we're just counting, right? We're not doing anything earth-shattering here, but you might be doing something, especially if you start going into different domains, that is much more interesting. If you're dealing with temperature readings, you might be looking at min, max, and standard deviation and variance over a window of time. You might also be looking for, if the current value is a new high, that might mean something. And especially if you start seeing things that are trending upwards, that might mean something as well. So this is a form of analytics being done, but it's being done at a stream sort of way on an ongoing fashion. So again, very relevant, very real. This is what you see in the real world. So I thought I would share it with you, and so that you're familiar with it as well. As always, if you have any questions about the stuff I talk about, let me know. I'd love to hear them. If there's anything I can do to help you finish out your assignments, let me know. You're nearly there. We're almost done. Fortunately, that's the case because we're almost out of time too. So again, if you have any questions, let me know. That's what I'm here for. Stay safe, and we'll talk again soon.